Today we are learning difference of perfect squares, where we are going to learn that how we can factorize one equation which has two perfect squares, and in other types when we don't have two perfect squares, what is the way to move forward and solve it. If we see the name itself, then it has two very important hints given. One thing is the difference. Difference means we subtract. And second thing is that perfect squares. It means we should have two perfect squares to apply this formula. So this technique is used to simplify some equations which we need to factorize in terms of finding the correct answers. But what is factorization? So factorization is a process of writing number of product of one equation. In this case, we have a square minus b square, so we'll be getting two product. For example, we have one equation given here. We'll be breaking down this equation into two parts, and these two parts are known as the factors of this particular equation. So let us start with the standard formula. So a square minus b square, where a square is a perfect square, b square also is a perfect square. So if we factorize into two parts, the answer would be a plus b, a minus b. So a plus b and a minus b are two factors of the equation a square minus b square. Now once we get the factors, we can verify that we are able to get the original equation by again multiplying them. It's pretty simple. So as we know how to expand, let us take the first element and multiply all the elements of the other factor. So if I take a, then I will multiply all elements of the factor, second factor. If I take the element b, then I have to multiply all the elements of the other bracket. So let us do it. So let's say if I multiply this part, which is a, which is a times b, but let us do a times a first. So if I do a times a, this becomes a square. Then I take element a, multiply it to b. So a times minus b is minus ab. Now if I take b, I multiply it to ab. So ab and b, they are same, so I can write ab here. Now b times, this is done, b times minus b minus b square. Now we know the like terms, unlike terms. So AB, they are the like terms, but one is positive, one is negative. So we can cancel them. So eventually we are getting a square minus b square if I do the times of the particular factors. So this is the formula we can apply. Now a and b are the variables. It can be x and y. It can be p and q. Doesn't matter depending upon the question. So we'll try to learn few different types of difference of perfect squares, in what situations we apply this particular technique. So let us come to type 1, where very simple numbers are given and then we are trying to factorize using this thing. Let's say the number given, the equation given is x square minus 4. The best way, it is 4 is not a perfect square currently in this current state. So we'll do x square minus 2 square. Now we can apply the formula. So what will the factor? X plus 2 times x minus 2. Second type of equation, when we have to convert the equation into perfect square. For example, I have 9x square minus 4y square. Here 9 and 4 are not perfect square. So what is the first thing? We will convert them into perfect square first. So 9 becomes 3 square, x square, 4 becomes 2 square, y square. Now we'll put them in brackets. So what will happen now? 3x whole square minus 2y whole square. Now first is one bracket, which is like a. Second, 2y is just assume like b. So basically it is a square minus b square. And what is the standard formula? We multiply and then we have two factors. So what are the two factors? We have 3x plus 2y. Other factor will be 3x minus 2y. And if you want to check the same process, you can take each element, multiply all the elements of the other factor. We can take this, multiply this, number 1, and multiply number 2, number 3, number 4, and you should be able to get 9x square minus 4y square. So these are the very standard types of difference of perfect square. So in part 1, DOPS, we have seen two types of questions that we can solve using the DOPS method, and we can easily do the factors. But there are a couple of advanced questions we apply the DOPS technique in senior maths. So keep watching our videos at Newton Classes Australia and look for advanced questions for DOPS part 2. Thank you.